Well, good afternoon. And as ever, they put me in the after-lunch slot because apparently I have more energy and can keep people awake. If you sleep gently, you are welcome to do that. Just try not to disturb the person next to you. They will let you know if you're a snorer, whatever you're thinking of here. So, okay. So, yeah, good afternoon. We're going to start off with a nice picture of some monoliths. Well, technically they're called trilithons, but these are some monoliths. I took a picture of these, when was this? Back in 2017. I went down to Stonehenge with my wife and kids because I'm an incurable romantic. It was the 14th of February, Valentine's Day. What should we do? Let's go and look at some 4,000-year-old rocks. Oh, wow. Yeah, that's the ultimate Valentine's present. By the way, if you have, has anybody actually been to Stonehenge? A few of you. Yeah, you might be wondering, if you have been, you're going like, what, Kevlin, where are all the people? Because it's absolutely heaving with people. This is the art of photography. They're all off the right-hand pane. It's a clever cut, okay? It's not actually that desolate. It's filled with people taking pictures, selfies. So what are we here to talk about? We're not here to talk about that particular set of monoliths. We're here to talk about something else. Modular monoliths and other facepalms. Now, if you think from that title that I am going to say bad things about modular monoliths, it's exactly the opposite. The facepalm is to do with how we have forgotten certain things collectively, but also how we've ended up naming and classifying things. And the way that we are very easily persuaded by certain vocabulary, monolith being one of them. You can find me in a number of places. I've kind of lost count of the places that I'm at. But having an internet unique name, Kevlin Henney, does allow me to be easily findable. I'm even still present on the deep fake porn site X, but I'm not quite as active there as I used to be. I'm an independent consultant, trainer, speaker, whatever. If any of this is of interest to you, architecturally or whatever, get in touch. I've just been running workshops here as well. I get a real kick out of doing that kind of stuff because people always share interesting stories and have interesting experiences about what they're doing. And that's actually what prompted the creation of this talk. It was actually a couple of experiences over the last 2 or so years. But let's start off with a kind of a conversation. Stop me if you've heard this one, or if you've experienced it. This has been one that's been happening over the last decade or so. We're going all in on microservices. Oh, really? Why? Our monolith is such a mess. Yeah, there's already grumblings in the order. Yeah. So, anyway, 5 years later, we're changing our architecture to a modular monolith. Oh, really? Why? Our microservices are such a mess. You see that we can parameterize this statement. But didn't you already try that? Oh, this is completely different. It's modular. Totally new approach. Yeah, there's the facepalm. So what's the issue here? It hinges on this and how we have or have not understood this word collectively. And how it has been taught. I mean, understanding doesn't come from just osmosis. It's a matter of practice and communication. Now, one of the things that prompted this talk is there's a couple of things. One of them is that at any given point, the number of people doing software development is it's an increasing number. I don't know how many developers there are in the world. I see various estimates, 20 million, say. It is of certainly millions, potentially tens of millions. And the question is, what is the relative experience through that number? And it turns out that it is not uniform in terms of age, that lots of people have been doing it, far more people have been doing it a very short time than people who've been doing it a longer time. It's one of those distributions, kind of power law. Okay, in other words, we are surprised by this. And in fact, in response to the one previous version of this talk, somebody put a comment on LinkedIn that kind of captured why I'm doing this talk, but also stopped me cold. They sort of said, yeah, this is really needed because over half people doing software development now have been doing it basically since the pandemic or after. And I suddenly thought, wow, that's the 2020s. That's really not very long. And given the age of software development is a surprisingly old profession. People often sort of say, oh, it's so young. No, it isn't. It's older than everybody in this room. There are jobs, roles, and concepts that are younger than that. We may not be as old as, say, medicine or physical forms of engineering, but actually it's pretty old. There's a lot of experience out there. The question is not age, but how we use that experience collectively. And we have we're very poor at history. And we're very poor at communicating these concepts. Now, I don't want to kind of like say, oh, you don't know it, therefore you're stupid. You're not. There's so much to know in software development. It's overwhelming. The rate of change is massive. And the amount of stuff to know is forever growing. So it can be overwhelming at that level. So let's take a more positive view. If you've not really had that experience outside a particular kind of architecture, then today you are one of today's lucky 10,000. Does anybody know what this refers to? XKCD, yeah, I'll walk through that in a moment. Because there's this point that people are not going to know the same thing as you. In fact, very much, I was having a chat with Chris Klug, who's running a session in parallel. He wanted to know what I was going to say, because we both want to go to each other's session. And he said, well, no disrespect, Kevlin, but you're of an older generation than me. I said, sadly, that is not disrespect, that's just scientific observation. It's the way numbers work, it's the way time works, as best as we understand it. And he said, so you've probably seen quite a few cycles. Yes, I'm dizzy. I've seen quite a few cycles, but let's actually draw on that and take advantage of that as a form of communication. And one of the things I noticed a few years ago, and particularly one event last year and one event the year before, when I was running workshops, some of the comments that somebody was saying, some people said, oh, I found this exercise really difficult. We were trying to partition up the logic of an application. And they said, yeah, we're not really used to this kind of thing because we do microservices, as if somehow microservices excuses you from having to do design stuff or to actually understand boundaries between concepts or maybe organize your classes in a rational fashion. It was like they sort of said, oh yeah, we have a get-out-of-jail-free card, we're doing microservices. And it's just like, oh, that's really interesting. Surely you should know more of this stuff. This should be second nature, but it was actually the opposite. It also occurred to me that, and this is the experience last year, that, and it occurred to me that what I was experiencing was that some people have never worked in any other architecture. And so therefore, all of their ideas have been formed within that. Well, that's fine, but maybe we need to do a better job of communicating, actually, this is built on an awful lot of other stuff that came before it. So the 10,000 thing is Randall Munroe basically saying, I try not to make fun of people for admitting they don't know things, because for each thing everyone knows, by the time they're adults, every day there are on average 10,000 people in the US hearing about it for the first time. Okay, and he talks about the Coke and Mentos thing. Does everybody know what the Coke and Mentos thing is? Oh, you don't. You are one of today's lucky 10,000. Watch Wreck-It Ralph. There's a really good demo in that. It's a great film anyway. But the point there is that we all learn things at different points. And it's a question of what we do with that knowledge. And sometimes people have an interesting thing. They often regard their skills as mutually exclusive to everything they've learned. I keep encountering this. I keep encountering people say, oh, I'm now doing functional programming. Actually, I don't encounter many of those. You can't get a job in functional programming. The one person who has got a job in functional programming will probably comment on the YouTube. Okay, bless your heart. But the point there is that people say, oh, I'm doing this. I don't need any of my OO knowledge. Or people who say, yeah, well, you know, I used to work in C, but I don't need to know any of that anymore. I'm now doing this. That's not how this stuff works. These all kind of overlap and build on each other. Principles you learn in one place. What you need to do is separate out. Here is the underlying principle. I can take that anywhere. And then here are the specifics that I may not need. That's a slightly different thing. So therefore, you need to sift through and sort your knowledge, and you will discover you know an awful lot more than you thought you did. So that's the first positive thing before we get into some of the negative stuff. So there is a kind of an observation here. Does anyone know who the guy on the right is? William Gibson. Anybody heard of William Gibson? The writer, yes. Anybody heard of the term cyberpunk? Yes, that's him. Yeah, Canadian writer. He was, given I was speaking about the pandemic, this is February 2020. He was speaking in Bristol, where I live. Given he's in his 70s, I can't imagine him coming outside Canada again to do a speaking tour, because he would be hitting 80 around now. He invented the term cyberpunk and all this kind of stuff, cyberspace. And, he has this quote that's often attributed to him: the future is already here, it's just not very evenly distributed. And this is a wonderful way of looking at some of the knowledge that we have. Collectively, as a discipline, if we are going to say that software development is a discipline, collectively as a discipline, we already know how to solve most of the problems we're encountering. Delivering most projects on time without unmanaged technical debt? Solved. We sorted that literally decades ago. The problem is distribution of that knowledge and the ability to articulate and put that into practice. It's not genuinely nobody's figured this one out. It has been figured out. It's just we're really bad at putting it out there. And the same here for structuring. So let's kind of explore this a little bit. So let's go back to where I started. These are trilithons, but let's focus on because there's three. Let's focus on the word monolithos. Okay, monolithos, monolith, literally meaning one stone. Okay, the Greek monolithos, one, lithos, stone. A single block of stone, especially one of notable size, shaped into a pillar or monument. You might want to use this with respect to certain code bases. You know, it's just like, yes, here is the monument at which we all worship and are sacrificed at work. You know, feel free to mess about with this quote. It's very repurposable. Okay, so that's the Oxford English Dictionary. So if I go to Merriam-Webster, a massive structure. Again, this seems to be saying the stuff. Now, you can understand why it is that a little over 10 years ago, people started using the term monolith with respect to certain classes of architecture. In actual fact, the term monolith was in use. I used it for decades. Monolith was just a big chunk of stuff. It did not refer to a specific architectural approach of putting everything in one process. We called that an application. That was architecture. So the point there is that sometimes you then start repurposing a word with some potentially negative connotations. And everybody's going around, oh, monolithic architectures, they're really bad. Well, hang on. There was no other choice at certain points in certain domains of software. But monolith came to acquire this. So everything everybody had done that was good was now daubed with this. And monolith came with a negative connotation. A large and indivisible organization or institution. And this is the kind of point, large and indivisible. It's the indivisibility that people were struggling with. And I kept wondering a few years ago, it's like, no, that application's not indivisible. Surely you've got everything organized into packages, subsystems, and stuff like that. Haven't you? I mean, surely that's what you've got. That assumption turns out not to have been true. So, this is what you want. You don't want those big immovable stones. You want this kind of elegant arrangement. Okay, this was done by my younger son many years ago with some stuff from Cleveland Beach. And it was just like, yeah, I took a picture of that. Very, very elegant. That's the kind of elegance you want in your architecture. And people came along and said, yeah, microservices. This is what we want. Small, elegant services. Okay. Now, let's clarify a few things here. Because this is the word that people kind of really struggle with. And I'm a bit of a definitions guy. I'm not somebody who says there's a thing called an etymological fallacy, that a word cannot mean anything other than what it originally meant. No, I don't believe that. Words drift, they move around. Their journey is fascinating because it tells you how things happened, how things played out. It tells you social things. But at the same time, there's a really strong suggestion when we talk about micro. Micro means extremely small, like really small. That's the idea. To differentiate it from maybe some of the overwhelmingly large services that occurred during the kind of peak SOA era, service-oriented architecture era. It's just like, oh, these things have got really big. That must be bad. Therefore, we need something better and newer and smaller. But we can't go around saying we're doing service-based architecture because somebody's already scorched the earth of that terminology. Okay? We can't use the same term. Okay? We have to find new language. Yeah, I actually had that with one client, actually with a different one. Sort of said, oh, yeah, okay, you want me to do a talk on this? You're trying to do that? Yeah, I've got a talk on this. It's one of my agile talks. And you can't use the word agile here. Why? Because we completely screwed it up. So we're going to use the word lean. Okay, so I just need to go through all my slides and just global search and replace, sorry, refactor, agile for lean. Now, you say, the point is, you say that that's a bit of a joke. It was not a joke, but I'd also worked with somebody who, when he was trying to convince people of component-oriented architecture, he just took his old object-oriented slides and did a global replace object for component, which also hints at what we're going to say, that the narrative, the story, the desire has always been the same. So micro means extremely small. And so whenever I've been in conversation with people, there has been this question of, what do we mean by small? And so one company, talking to two teams, online call, I said, so just to clarify, for purposes of what I call calibration, you always need to understand where somebody's coming from, because they always complain about their problems. And sometimes you have what I call a moment of calibration, when you really understand what their problems are or are not, okay? I remember once sitting down with somebody complaining, one company I visited, unmanaged technical debt. Oh, we've got such a problem in our code base. Oh, it's terrible. It's this, it's that. We spent the first day talking about that, and I said, okay, that's really interesting. Maybe we should look at some code. I'd really like to see some of your code. We talked about all the stuff and the building, the customers, all the rest of it, day one. Day two, sat down with one of the developers, going through the code base, and he's just, I've got to say, it's looking really good. I'm looking at the tests. Yes, they have tests. They have lots of tests. The tests are pretty good. We refactor a couple. We do a few changes here and there. And then he shows me, pulls up a method. And he says, Kevlin, this is what I'm talking about. This is the kind of problem we have. This method is too big. How big was it? 40 lines. And I'm sitting there going, okay, I've just had a moment of calibration. Sure, it could be shorter, but I know companies that would kill for methods that short. If you regard this as bad, your quality sense, your radar is in a completely different place. And that immediately told me, I don't think your problem is what you think it is. It's something else. It turned out it was something else. And it was, their development slowdown was something else. But on the other hand, I spoke to one guy, and he sort of said, oh, yeah, could you help me with this? I'll just go and print off this function. I've got a little question about this. He was old school. He genuinely went off and printed the function. I didn't realize that, because it was the beginning of lunch. And I said, oh, we can look at that now. And he said, oh, no, I'll speak to you at the end of lunch. And I thought, well, I don't want to interrupt anybody's lunch, just because I'm a consultant and don't have anything to do at lunch. That's fine. He comes back, and I realize why he wanted the whole of the lunch hour, is to print out the function. And he said, yeah, I've got a little bit of question about this bit here. And I'm just looking at it, goes like, is this a joke? Is there a camera in the corner? You've just printed out half a tree at his one function, and you're going to draw your attention to one small thing. Honestly, that one small thing does not matter. The world is burning, and you're a little bit worried about the small detail. A moment of calibration, understand where people are. So I had this with this company. I said, so your microservices, how big are they in terms of lines of code? Now, sometimes people think, oh, lines of code is a terrible measure. If you're one of those people, I have a simple thing to tell you. You're wrong. Lines of code is a perfect measure of the number of lines of code you have. No other measure comes close. It is an exact measure. Now, why does that matter? Because it's a measure of amount of stuff that cognitively, as an individual, I have to experience and read through to know. My question to you is, when you walk in the morning and you pull up the code, are you presented with a wall of stuff, or is it, oh, I understand that? That's literally it. If when you walk in and somebody says, our service is 1 million lines of code, oh, it's a microservice, our microservice is 1 million lines of code, that is a fundamentally different experience to somebody walking in and saying, yeah, it's 4,000 lines of our code. These are two very different personal developer experiences. Genuinely, I don't actually care about the number of lines of code, and I'm not going to read anything into it in terms of, I'm not going to be dumb enough to read productivity into it, but it is a sense of the experience. What am I looking at? How much do I have? If you tell me your methods are 1,000 lines long, I have an exit strategy. It's called the door. I will leave. I don't want you to leave, because somebody needs to look after it. But that's the point. So let's talk about this. What do we mean by microservices? There is a sense of scale here, but let's explore some definitions. Microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. Yeah, seems reasonable. These services are built around business capabilities, so we're taking the technical, we're aligning it with the organization and its goals. And we're not just anchoring ourselves in the technical domain. And independently deployable by fully automated deployment machinery, connecting to the kind of the CI/CD universe. So we've got we've got an idea of going from all the way through from requirement to actual usage. Well, that's kind of like, okay. Okay, how are we going to build this? We're going to define a subset of the system which is small enough to bring to an operational state, then build on that subsystem. This strategy requires the system be designed in microservices which can be realized, tested, and modified independently, apart from the conventions for inter-service communication. Now, when we come to those, we need to focus on that idea of an interface and contractual. So a microservice is a unit of composition. Okay, the suggestion there is we are building something larger with contractually specified interfaces. Our focus is on the interface, not the implementation. An interface is not merely syntax. It is semantics. It's what is allowed. What are we expecting? It's also advertising failure modes. Okay? And explicit context dependencies only. A microservice can be deployed independently as a result of that. So this idea of a contract to deliver a certain amount of service, clients of the interface depend on the contract, not the implementation. Okay? So we're trying to avoid implementation leakage. This is good from a comprehensibility point of view, but also independent evolution, technical independence, technical evolution, and so on. This is good. So how are we going to go about it? So every service is characterized by its knowledge of a design decision, which hides from all others. We want to separate this out. Okay? We want that kind of stability. This kind of idea of information hiding. It's interface or definition chosen to reveal as little as possible about its inner workings. We can even say there is a philosophy to this, and it is quite simple. Write services that do one thing and do it well. Write services to work together. They are composable in that sense, or the composability is at the system level. To me, this means only messaging, local retention and protection, retention and protection, hiding of state process, and extreme late binding of all things. We do not assume anything about the other services which allows us to do late deployment stuff. Now, some of these quotes, some of you may be thinking, is this right? I mean, this all sounds fairly sensible. But, because within these quotes is bound the strength and the will to create microservices. But all of you have been deceived. For only one true quote was made. This quote comes from Alan Kay. I've just changed a couple of words here and there. Object-oriented programming, to me, means only messaging, local retention, and protection, and hiding of state process, and extreme late binding of all things. If you think that object orientation is about having something with lots of auto properties and a class called manager, and using dependency injection, you're one of today's lucky 10,000. Because that is not object orientation. That is something else. And I get a lot of people go, oh, object orientation, that's all of this. It's like, only if you're doing it really badly. That's my moment of calibration. That's not really the way. I mean, it might be popular, but that's not the original vision. Alan Kay was one of the instigators and developers of the Smalltalk language. If you want to know how old that idea is, the original Smalltalk was Smalltalk 72. The clue to the year is in the name. Smalltalk 80 is the one that was most influential. Okay? Smalltalk 80, although it's not a language that is in any kind of currency now, it's everything as an object. It has a uniform elegance to it. And the community that worked with Smalltalk kind of gave rise to a number of interesting things, some of which you may have heard of. For example, extreme programming and agile development, test-driven development, the wiki, patterns. Have anybody heard of these ideas? Yeah, you might not have heard of Smalltalk, but the community created many of these things. In terms of a language, in terms of its legacy linguistically, it gave us uniform object models. If you like, Ruby is probably the language that has the most Smalltalkishness to it. Although if you've ever experienced Objective-C, that is a perfect car crash between C and Smalltalk. I mean, from a language design point of view, it's absolutely disastrous. But if you've experienced that, then at least you have some idea of what we're talking about here. This is the Unix philosophy. Write programs that do one thing and do it well. Write programs to work together. Doug McElroy. This was actually captured in Peter Salas's book, Quarter of a Century of Unix, which was published in the 1990s. Every module is characterized by its knowledge of a design decision which it hides from all others. Module. Its interface or definition chosen to reveal as little as possible about its inner workings. This is Dave Parnas's paper, 1972, on the criteria to be used in decomposing systems into modules. He lays out the modularity. He did not invent modularity, but he gave us a way of thinking about it. And this kind of, it's his work that gives rise to phrases like information hiding. So this paper and a 1971 paper that introduced this, its relation to data abstraction. The idea of, I can't know everything, so everything shouldn't be coupled to everything else. So maybe if they've got a difficult or volatile design decision, wrap it in something so that we depend only on the interface. And we can see that present in many paradigms. It's not unique to a single paradigm. Module here is used quite broadly. Butler-Lamson's 1983 paper, Hints for Computer System Design. An interface is a contract to deliver a certain amount of service. Clients of the interface depend on the contract. The word contract you may have seen pop up in a number of places. There's an idea called design by contract from Bertram Meyer. That's the late 80s. This is the earliest I've been able to find the contract metaphor. The idea of the contract metaphor is we establish different roles. We're often thinking in terms of like, we're all developers, we all mess around in the code. The idea of the contract metaphor is to say, even if you are using a different abstraction, you are playing one of two roles. I am using the abstraction, I am creating the abstraction. I am a client or am I a supplier? And to try and understand the boundary between that, and to try and enforce that boundary. A component. So this is component-based development. A component is a unit of composition with contractually specified interfaces and explicit context dependencies only. A component can be deployed independently. This is Clement Sikorsky. This is the mid to late 1990s. Component-based development, at that point, is beyond object-oriented programming. Yeah, well, it turns out that you don't just have one paradigm replace another. These are all synthetic. They combine at different levels of scale. Define a subset of the system which is small enough to bring to an operational state, then build on that subsystem. This strategy requires the system be designed in modules, which can be realized, tested, and modified independently, apart from conventions for intermodule communication. E.E. David, 1968. The original software engineering conference, sponsored by NATO, took place in Garmisch in Germany. Quite important in the history of software engineering, a widely misunderstood and unread document. It turns out it contains some really interesting stuff. And as a general point, 1968, so there is a kind of a myth that goes around, and I do try and bust the myth every now and then, today being one of those days, that this was the conference that invented the term software engineering. I've even seen that people say, oh yeah, software engineering was invented to deal with large defense projects for NATO. This is absolute nonsense. Something else that happened in 1968 is actually related. This is picture Earthrise, one of the most famous pictures of the 20th century, and one of the most positive famous, because there are a whole load of crappy ones, really negative. But one of the iconic images was taken Christmas Eve, 1968, the first time humans had been into deep space. Technically, deep space is defined as anything above low Earth orbit. The moon is 400,000 kilometers away. The ISS is 400 kilometers away. There are the orders of magnitude different between these are just vast. The first time humans have ventured out this deep. In theory, in the next couple of months, they're going to do it again. It's only been half a century. No rush. But the point here is that it turns out that software engineering was coined by Margaret Hamilton, who was at MIT, and MIT was subcontracted to develop part of the Apollo guidance computer system. So this is the mid-60s she coined that term. This is the stuff that was happening in 1968. We had not even set foot on another world, and people were already talking about modularity. Just as a small point, also in 1968, one of the best films, I Will Fight You, one of the best films, 2001: A Space Odyssey, showed a moon landing. Awesome film. If you enjoy Interstellar and have not seen this, go and see this. You'll understand Interstellar more. It's very interesting. Also, minor point, same typeface is used. Gil Sans, as on the software engineering thing. I don't think that was by design, but I love a coincidence. Anyway, back to the narrative. This is the only quote that was actually about microservices. James Lewis and Martin Fowler. Okay? It is actually, I didn't place any of the words. So here we have a definitional thing that somewhere along the line, what we thought of as this became this. And it happened not once, but with every single advance. It happened when people talked about how do we do procedures and subroutines well. It happened that we ended up with monolithic mush. Observations like you can write Fortran in any language. This is the kind of stuff, procedural programming, okay. And we keep seeing this cycle. Object-oriented programming. Oh, we've got manager objects and anemic domain model. This is terrible. Oh, services. So, Alan Perlis, actually one of the people present at the 1968 conference, and also recipient of the first Turing Award, made the observation, in the long run, every program becomes Rococo, which is beyond Baroque in its detail and intricacy, and then rubble. This seems to be the fate of many, many systems. So what happened here? We had this idea of monolith, and people were using monolith to be negative. If you go around saying, oh, our code is a monolith, you don't even need to say anything else. You've already told people that it's bad. But actually, what they actually, and then we ended up with microservices. Microservices, for a period of time, was an unconditional good. But as with any architectural choice, all of these are conditional. Okay, there's not an unconditional good here. The real issue was that what people, and then we come to this term modular monolith, and it's like, wait a minute. It goes back to that moment I was saying, how else were you doing your monolith? Were you not structuring your process into small parts according to some kind of rational criterion? Choose your paradigm, I'm not going to judge. But what, were you not already partitioning it? I mean, I know one project that, you know, this goes far enough back, that the reason that they broke things into smaller modules was because the editor didn't have enough memory to contain the source files. They were so large. But we solved that problem. That's what 32-bit computing was for. It allows us to have bigger source files. But then I also saw people hit the limit with compilers. I didn't know it was possible, but a guy I work with, he actually managed to break the compiler. The compiler said, I cannot optimize this, there's too much. So that had to be broken down. People always find a limit somewhere. So this term's coined by Simon Brown back in 2015. So we're over a decade on. It's not a new term at all. Simon made this observation. The design thinking required to create a good microservices architecture is the same as that needed to create a well-structured monolith. In other words, microservices offer a number of things. There's a number of trade-offs involved in terms of complexity and performance, simplicity, and so on. And the point is, you can't just go to it because somebody said microservices gives you more modularity. It doesn't give you more modularity. It gives you exactly what you've had available for decades. It gives you a bunch of other stuff related to the runtime environment, the deployment environment, and it can reinforce aspects of your cultural structure and your team structure and how you choose to develop. But notice I use the word can. It's not mandatory. There's not a microservices manifesto that says if you do not follow this, you will be thrown out of the club. And the point there is that it allows you the possibility. But if you're not tuned to that, you're going to drive straight past it. It turns out that having worked on architectures that were classically monolithic, but really well structured, it's just like, yeah, I've worked on monolithic architectures that are far more elegant, more maintainable, quicker to deploy than some microservices. It tells you that the choice of I'm going to do monolithic versus microservices is not enough to guarantee something. There's a bunch of other factors as well. As Simon says, this begs the question, if you can't build a well-structured monolith, what makes you think microservices is the answer? You will take that same style of thinking, but now microservices is more likely to penalize you. It brings in other complexities. So you won't get the benefits that you may have hoped for. So really what we should have been saying, the missing word. What's the missing word? The missing word is messy. The problem is not that you have a monolith, it is that you have a messy monolith. Now, then we can start talking about other factors, but once we start using the right words, Because it turns out that, guess what? Microservices can be messy as well. Oh, you mean I can put words in front of my architecture? Right, yeah, that's the case. Architect Clippy, love this one. I see you have a poorly structured monolith. Would you like me to convert it into a poorly structured set of microservices? And now, thanks to LLMs, we can do that instantaneously. What used to take teams, weeks, we can produce vibe-based shit in no time. Awesome. Again, sensibility and awareness is actually the differentiator. So, modular microservices is what people wanted, but they never said it. Modular monoliths is what people wanted, but they never said it. So let's look at this word modular. Modular design, modular architecture. This is not a new idea, and it's nothing unique to microservices. So here we have Mars. We've done the moon, we've got a picture of Earth, let's move to Mars. This is a quote from Gerhard Holtzman, who is basically the chief engineer, chief developer of the source code, the code for Mars Curiosity, which landed on Mars in 2012, if I remember correctly. It's around that time, and its sibling, in 2021, landed on Mars, Perseverance. The codebase was written in C99 with an awful lot of static analysis, and it ran on VxWorks, basically fault-tolerant real-time operating system. And what was interesting is there's a talk, and there's an associated article. He says, there are standard precautions that can help reduce risk in complex software systems. This includes the definition of a good software architecture based on a clean separation of concerns, data hiding modularity, well-defined interfaces, and strong fault protection mechanisms. That's 5 particular qualities he has identified in this list. I'm sure we could identify others, but he's chosen to pick out 5, only one of which is unique or particular to the class of software. And there's certainly no web activity on this. The point here is that this is a general overarching principle. Here are the 4. So strong fault protection mechanisms is kind of the one that you kind of need to care about. I often joke, it's just like, this matters a lot for space-based software. You know, if I'm running an application on my phone and it crashes, that's really mildly annoying. If I'm playing a game on my phone, I don't need it to be fault tolerant. It's annoying, but it's non-critical. I think that the cost of Mars Curiosity is around $700 million US. If that crashes, you can't just reboot it. You can't just send Matt Damon to Mars to hit the reboot button. That's not how this works. You know, first crewed mission to Mars to reboot dead rover. No, that's not why we do it. Send out the repair guy. You really, you know, you get that wrong, that's nearly $1 billion down the drain. Fault tolerance is hugely important in this class of software. But that's not the same for everything. But the other 4 things I think are interesting. Clean separation of concerns, that's 1970s. Data hiding, 1970s. Modularity, 1960s. Well-defined interfaces, 1960s. These are not new ideas. How they are expressed in each generation with each wave of technologies or paradigms, the articulation is a little different each time. The underlying principles, it turns out, are remarkably stable. And so that's the thing we need to kind of focus on, is the stability of these things. We have this myth that technology is fast changing, and it is a myth. Not all technology is fast changing. It's like parts of it change very, very quickly. Parts of it change really, really slowly. Really slowly. It's like the cross-section of a river. The top may be fast-moving. It might be chaotic and turbulent and rapid and moving in many different directions. But by the time you get down to the riverbed, it's much slower, smooth flow. We see the same kind of layering in tech. Okay? We see that with programming languages. Just think about the programming languages you and your colleagues typically use. You may even find that some of those programming languages are older than you. That's actually the norm. Most languages are older than the people that are using them. Okay? The point there is that that is closer to the bed. That's much smoother. There's a bunch of stuff that's happening, innovation at the surface, but it doesn't all change uniquely. So the point is that there are principles and ideas that are stable, and their articulation varies with each generation in tech iteration. So let's pick on the word modularity. Property of being modular. Not very helpful. Use of modules in design or construction. Okay, design or construction, we can get that. So when we talk about this in software, what are the modules? And the problem is that this word is one that moves around quite a lot. So I want to separate out. In fact, I could separate this out into multiple different definitions, but I'm going to just pick 3 in terms of areas in which modularity applies. The develop stage, the develop aspect, the development. In other words, I see the modularity in my source code. I see it supported through the constructs of my programming languages and how I choose to organize my files and things. Okay? That's the development side of modularity. Then there is the deployment side of modularity. Sometimes we have, so for example, the original discussion and a lot of the original discussions around modularity, a lot of them focused on this, and there were programming languages that exhibited modularity. And if you were using, for example, modules in a language, there's a very good chance they correspond to this. They are a unit of development. They have syntactic meaning within the language. Yeah, it could be JavaScript, it could be Python. Module is a construct within the language. There's an awareness. You'll get error messages in terms of modules. You know, there's a whole kind of concept there. But it gently bleeds into the deployment side of things. And that, just to give you a sense of, I've mushed everything into 3 categories. There are a few others. Build. But I'm going to, that straddles this. The idea is like, I can have units of modularity that are the things that I put out there. Here is a thing, and I'm going to deploy it. This is where you end up with kind of like the more, Java ends up using the word module like this. This is kind of the OSGI bundles classic history. It's the idea of packages, the things that I ship. We'll come back to the naming in a moment, because it's an absolute minefield. But there's modularity at that level, and that may be in addition to or different to or the same as the development time thing. But the word modularity here has a slightly different connotation. And then we have the runtime. And microservices is kind of in 2 and 3. The runtime is, when I look at my memory, if I look at the process table, do I see separate units? Is it laid out like that? Can I say that these are modules? Do they exhibit modularity? So the thing is, the word modularity applies at all of these. And you can feel free to go through more stages, but I just thought I'd pick 3. The point here is that these are different aspects. Stages actually makes it sound a bit sequential. I should really think of it as being different domains of interest and execution or engagement. Okay? The first one is very much about the source code. The last one is very much about the runtime. And then we go through all shades in between, and we can choose to name them and separate them how we want. But modularity is a word that can be used in each one. The problem with such a word is that it's not immediately obvious that one person talking about modularity is talking about the same thing as another person. I'm sure we've all had conversations where apparently we're using the same words, but we're having 2 very different conversations. Yeah? Module and modularity are exactly that. But it is significant because these, I'm going to draw a definition from this book, from Paul Dyson and Andy Longshaw. This is quite an old book, so I'm not, it's good, but I'm not going to necessarily recommend it because this predates pretty much everything that you would normally talk about. For example, microservices as a term had not been invented by this point. DevOps as a term had not been invented by this point. Patterns for high capability internet-based systems, the cloud was barely a thing. So the point there is a lot has changed. So some of the advice here was good for its time, but may not have, there's better things to do now. But nonetheless, the articulation of principles is really good. They have a really good way of thinking about the architecture of a system. We have lots of different definitions for architecture, but what I like about this, our position is that an architectural definition is something that answers 3 questions. I like this kind of approach, is rather than saying architecture is, it's basically, I'm going to ask you 3 questions, whatever you say, that's your architecture. Okay? And it's a really good way of teasing things out. What are the structural elements of the system? Notice they sidestep the use of the word module, component, and all these other words which have 1,000 different meanings at different times. Structural element. What are the things? If I were to draw a diagram up, what kind of things would the boxes be? Or the bubbles? Yeah? And this is at different levels of scale. You don't just have one kind of thing. It's the idea of like, well, I have functions at the core, at the finest level. I might have development time modules, and then I might have at runtime, I might have processes. These are all the things I might want to talk about. So what are the things, when you talk about your system, what are the things, and what are the range of granularities that you cover? If you notice there's a bit of a gap, we're only talking about the big things, but not the small things, that tells you you have, yes, a gap. So, in other words, what are the things that we talk about? What are the things we would draw if we were sketching it up on a whiteboard? And if you don't have a whiteboard, I have to say, if you don't have a whiteboard, now is a good time. Okay? Many years ago, I turned up at a conference, and everybody was trying to sell tools for software development. And so I looked around, and I could see people kind of like being a bit indifferent. And I said, how many people have a whiteboard budget? Are there any whiteboard vendors here at the software conference? No, because they make an absolute killing, I'll tell you that. That's the missing ingredient. There's nothing magical about that. It's just a way of collaborating. Okay? If you're doing this in person, great. How are they related to each other? Oh, okay, so what are the lines between your boxes and bubbles? What are the semantics of those? And that can be anything to, we have an HTTPS connection. That's a line, that's a relationship. Or I am calling an object in another thread. That is a relationship. I am an object with a reference to another object. I am a class inheriting from another class. Okay? I am an implementation of an abstract data type, an API level concept. All of these are relationships. You say, here's a thing and here's another thing. And there is a relationship there. And that's basically your architecture, except for one more question. Why? What have we got? How are they connected? And why is it like this? What's the underlying rationale? And that gives you effectively a paradigm and a philosophy, and it allows you to know about your system. But this is really helpful, because once you start doing that, you realize that module here can mean anything that is structural element. However, as I've already intimated, there are only two things, hard things in computer science. The Phil Carlton quote. If you've not come across this one, this is a good one. Cache invalidation and naming things. We will not be talking about the first, although you may care deeply about it if you're doing microservices. But the second, it's hard. Why is naming things hard? Because we're trying to say what we mean. That's one of the hardest things that human beings do. It's really difficult to establish that sometimes, so we have to kind of iterate a bit. But we have really screwed this territory up. We've got words like module, component. Sometimes they mean the same thing, sometimes they mean something different. Sometimes people use the word component to mean a runtime deployable unit, like an assembly. Sometimes they use component to merely mean part of a composition. A class is a component. A function is a component. In other words, it's a thing that can be part of a composition. Package, oh my God, we've really screwed this one up. Java, I'm looking at you. Java screwed this up worse than anybody else. And I do like it as a language, but it screwed it up. A package, what is a package? Well, in the real world, it's a unit of delivery. I mean, literally, that's what it is. In Java, oh no, it's not a unit of delivery. It's also sealed and contained. In Java, it's absolutely not. Anybody can extend and add to a package. There is no boundary. It's basically a namespace. But it's a namespace with really a lot of leak. It's a terrible, terrible name. But it is a namespace. It's not a module. It's not a component. It's none of these things. They missed an opportunity. But nonetheless, that's the prevalent word. We also have UML use the term package. But these days, the prevalent use of package is to do with, well, we use package manager. It's to do with the delivery, because that's what the metaphor means. Okay? Naming is hard. I get it. Then we've got service. Oh, wow, yeah. We used to talk about functions as being service providers. A function offers a service, but now we have services offering services. And then we talk about process, which is also a bit of a mess, because sometimes we mean operating system process and sometimes we don't. And you are led to, it's perfect grounds for a quiz. Can you guess what Kevlin's saying now when he says process? Process-based design is not to do with operating system processes, for example. When we say Erlang is a process-based language, we're not talking about operating system processes, but we are often talking about processes in terms of units of isolation at runtime as being operating system processes. So again, there's a lot of scope for miscommunication, but modularity applies in all of these. So what are the trade-offs that we care about? Well, the trade-offs that we care about are kind of a very simple way of understanding some of the trade-offs. It's kind of a right-hand rule. People have this habit of talking about functional and non-functional requirements. I'm just going to simply ask you, please stop. Non-functional doesn't tell you what it is, it tells you what it isn't. Yeah? The point there is that we're kind of missing something. So if I drink from this, I'm drinking not beer. I haven't told you what I am drinking, I've told you what I'm not drinking. If I drink from this, I'm drinking not coffee. Oh, I guess it could be homeopathic coffee, but that's a criticism of homeopaths rather than coffee. The point there is I haven't told you what it is. Our job as software developers is to tell you what it is, not to talk about, oh, this system is not that. What are you going to develop this system in? Not C#. Okay, well, that narrows it down. And how are you going to deploy these packages? Oh, not NuGet. Just what? So you haven't told me anything useful. What are these requirements? They're not functional. But also, by the way, not functional in English. When you say non-functional, it means broken. Just in case you're having any difficulty with the English language, which is a treacherous piece of linguistic landscape anyway. But non-functional means broken. Yeah, talk to your clients about it. What are your non-functional requirements? We want it to crash every Tuesday at about 3 o'clock. We want it to not function at that point, but we want it right back up 5 minutes later. No, you have no non-functional requirements. Tell me what it is. So there are lots of different ways of subdividing this, but I'm going to keep, because I've got a limited number of fingers and limited ability to make them roughly right angles, we're going to put most of these that are about the runtime into the operational bucket. We can call this executional, if you'd like. I'm not attached to the name. By functional, I'm going to mean semantics. The stuff that can be, the stuff that normally appears in user stories that is easily verified using things like unit and integration tests. The how does it run is in the operational. That's where we start talking about qualities of service and things like that. The developmental side is also non-functional, but it has a different narrative. It's what is the developer experience like? The maintainability, the modifiability of that code, the modularity of the code. What's it like to be a developer in that thing? That's a different question. What's it like to develop in the system? Now, these are obviously not perfectly at right angles, but then again, neither are my fingers, so it is an approximate guide. But it allows you at least a degree of separation that you don't get with the binary cutting of functional, non-functional. Now, why do I care about this? Because I want to focus on these two for a moment, because there's a trade-off. And that's the whole point. When people are making these decisions, we need to understand that a trade-off is about trade. The clue is in the word. It's embedded there, but we forget it because we use it so casually and so frequently. There's a trade. And sometimes you're trading between one thing and another. So, for example, I might say, we need better performance. We need better availability. We need better something at runtime. And we will emphasize that. And then we will say, but actually that's going to make the code more complex. It's going to make our deployment manifest a little bit bigger. We're involving more technologies. So it doesn't mean when I say the arrow goes down, I'm not saying the developmental quality necessarily goes down. The development becomes more complex. You have more considerations. Of course, if you screw it up, that's also a downward arrow. In other words, your complexity comes from accidental complexity rather than dealing with the complexities that the technical combination gives you. But the idea is we might consider that an acceptable trade. What we're doing is literally a trade. Because we need these runtime qualities, we are prepared to pay, and we can afford to pay these development. Yeah, we can afford a little more complexity in the development. That's fine. But sometimes it's a virtuous thing. We get a benefit. It's like, hey, guess what? You're giving me a free offer, and actually, if I take this choice, I get benefits all round. And that's what people are kind of hoping is a magical thing with microservices. But the problem is that's not how it works. You can sometimes end up with, hey, this becomes easier, but the performance gets worse. You can end up with, this is harder to develop, and the performance is worse. A lot of people have kind of experienced that one as well. But the key message here is that it's not as simple as we make it more complex, therefore it goes faster or gives us better availability. Or if we choose this, everything gets better. The idea is that this is a deeper consideration. Architectural considerations often are. There is a greater complexity. You're not guaranteed that one goes up, they both go up, or one goes up, the other goes down. There's a much more subtle dependency on the context. So from that kind of point of view, it kind of leads us to this kind of question. Given that we talked about this kind of old stuff, let's talk a little bit about, wrap up with kind of consideration of what that means. What are the things that we need to be spotting, whatever paradigm choice, whatever architectural style we embrace? There are a number of considerations that are common, and they are relatively timeless. So Sam, oh, actually, KubeCon London 2020, so 6 years ago, probably on this stage. Is that correct, Sam? Yeah, it's probably statistically this stage. The modular monolith, of course, is using cutting-edge ideas from the early 1970s around structure programming, which some of us are still getting to grips with. That is a very deep truth. I happen to be quite into history of programming, and so I go around buying old books. This book was published in 1972. I was not developing software in 1972, okay? So I'm quite interested in what people were actually saying. So I've got a bunch of old books that are kind of historical documents, and they're kind of interesting. This is where, by the way, a number of ideas come from. We'll come back to one of them in a moment. Here we are. We've taken our single process monolithic application, we've broken it down into modules. Those modules, if we get our module boundaries right, that's the bit that's important. It's not the monolith aspect, it's the modular aspect, the boundaries. It turns out the boundaries are the thing that we care about, and that's what most paradigms ultimately are about. We see the boundaries within our code, and boundaries exist at different levels. Function, class, package module, whatever, etc. But also they exist in terms of how we consider the deployment. There are boundaries there. How we consider our teams, there are boundaries there. How we consider the runtime. Does this happen in this process or over in a process near us or in a process that is truly remote? There's a question of trust and relationship there. It's all about the boundaries. Yeah, you need to work out what the boundaries are. The boundaries, for example, within your home are quite different to the boundaries between your home and the outside world. Okay, so, you probably have a lock on the outside, the door to your house, but the reason you have a lock on your bathroom is for quite different reasons, okay? And most of the doors within your house don't have that, but there's still boundaries. There's still the strength and the meaning, the semantics and significance of the boundaries are different. That's the question we need to be asking, whatever technology we embrace, or whatever wave of architectural style takes hold in our company. So, yeah. What was Parnas saying back in 1972? Benefits of expected of modular programming are, and stop me if some of these sound familiar. Managerial, development time should be shortened because separate groups would work on each module with little need for communication. Who's heard of Conway's law? So a number of you have. Okay, Conway, 1968, that's where that comes from. So this is written in the wake of that, okay? It's that idea of like, yeah, we could organize our teams according to module ownership boundaries. We often see this manifest when people talk about microservices and team topologies. There's an alignment there. It's not a new idea. It's just an idea that when we keep trying to re-articulate and think about and reason about and present in new ways. Product flexibility. It should be possible to make drastic changes to one module without a need to change others. That sounds strangely familiar. Comprehensibility, it should be possible to study the system one module at a time. The respect for the human bandwidth limitation, our capacity. The reason I ask about lines of code or how big your functions are is not because I truly have a hard limit that I expect and demand or anything like that. That's not it. It's I want to know how much stuff you're dealing with. Yeah? One organization I visited years ago, visited them over a number of years, and there were two of the teams that I dealt with. One of them had 100,000 lines of code, and the other had 1 million lines of code. What was interesting is that it took me a while to realize that comparably they had similar functionality. They were both distributed systems, but they had similar functionality. They didn't do the same thing, but it was comparable. If you broke the systems down into user stories, function points, whatever approach, they would be about the same size. And yet one was 10 times larger in terms of source code than the other. You can guess which system had the tests. You can guess which system where they went home on time. You can guess the system had the least outages. That's why I'm interested in the numbers. It's just like, how much stuff have you got to deal with as a team, as an individual when you walk in? It's not a magic number, but this is a point. We are ultimately somewhere in there. And by the way, if you're saying, oh, but AI has context limits as well. It turns out it's really good with small stuff and not so good with big stuff. This is not new news. So we have this idea. Separation of concerns ultimately dates back to Dijkstra. Separation of tasks is a good thing. On the other hand, we have to tie loose ends together again. Do we have a way of understanding this? Yes. Here's another glorious book from the 1970s. I mean, I don't even have to say that, do I? I mean, look at the cover. I mean, that's nice. It's got 1970s written all over it. People don't produce book covers like this. So, Tom DeMarco, structural analysis and system specification. What are we talking about here? Coupling is a measure of the interdependence of modules. How are things stuck together? The higher the coupling, the more likely it is that changes to the inside of one module will affect the proper functioning of another module, no matter what construct we are referring to, and no matter whether we are referring to this at development time or runtime. Obviously, coupling is something we would like to minimize. Not eliminate, minimize. If you eliminate it, you don't have a system. You have a bunch of things that are just sitting there doing nothing. This is the original information hiding paper from Parnas, 71. Connections between modules are the assumptions which the modules make about each other. It's not always about the obvious source code connection. There are assumptions that they share, sometimes copy and pasted. Sometimes you have to know this from the developer. Oh, I had assumed that that was single-threaded. Oh, that doesn't work. I had assumed that we were all going to be using this version of our data format. And it's never stated anywhere except somewhere in a repo in a version. There's subtle dependencies. These two depend on each other even though they never talk to each other directly. But they speak through JSON. They speak through the database. There is a convention there. So dependencies goes further than people think it does. So the idea is that you want to end up with something that's like, doesn't matter what these little boxes represent. You want something that has got this kind of separation and clear notion as opposed to the tangled goo that we encounter in many systems. I don't care if I'm drawing services or classes or whatever. The point here is that this second one is clearly more tightly coupled than the first one. It's less comprehensible. We care about the cohesion. The conversation around cohesion, the degree to which something is integral and whole, has been muddied by misunderstandings around what's been coined the single responsibility principle, which is actually not about responsibility and is not a principle. Cohesion is the underlying concept that we care about. It's a measure of the strength of association of the elements within a module. A highly cohesive module is a collection of statements and data items that should be treated as a whole. It's a one thing. It's not a one responsibility, it's a one thing. Any attempt to divide them causes us pain and anxiety, although DeMarco doesn't say that. So we have this idea. Actually, I'll skip that bit. The point there is that we want this kind of separation. And kind of when we realize that, it brings us to this kind of timely conclusion that in terms of our knowledge, everything has been said before, but since nobody listens, we must always start again. And I guess that's normal, and we should be comfortable with that, but we should at least make the effort to go out there and do that. When we are making these decisions, software development is as much a fashion industry as it is a technology industry. And that doesn't mean that some of the new ideas are necessarily bad, but it doesn't mean that they replace old ideas. Many of them build on or have the assumption. Many of the people who work, for example, with microservices effectively do so because they have a stack of knowledge. Your full stack. People always talk about full stack development. What it normally means is I work in JavaScript and talk to a database. Which is really quite a tiny sliver of the stack. But what is our full stack of knowledge? And we are really bad at learning the principle and taking that to the new technique. What people really cared about is I care about separation of things, and we shall call some of those things modules, and we shall use other words for other things, but each shall exhibit modularity. I shall care about the relationships, and what I will do is balance that off against things like the runtime needs, the deployment needs, and so on, and I'm going to make a trade. Okay? It's a system of springs, and I'm exploring that. But there's no silver bullet that is going to somehow magically solve all the problems simultaneously. And we need to respect that. That's the one thing that we do genuinely need to learn. Now, I hope that has been useful, thought-provoking. We're out of time, but I am around if you have any kind of further thoughts and questions. Thank you very much for your time.